Thing physical study about 15. We're in chapter 9 about the static equilibrium of a rigid body. And so we've already gone through the conditions of the equilibrium. And now we're going to study about a very fundamental idea, and it's the center of gravity. Let me write it in an orderly fashion. Center of gravity. All right, so what's that? The center of gravity is a point in our body that holds all its mass. So let's say we have a rigid body, but it's not symmetrical, right? And there is a point, maybe here, where all the mass is concentrated. There's a fine line between center of gravity and center of mass. Well, the center of mass is when there's a homogeneous distribution of mass in all directions. And center of gravity is the same thing, but instead of mass, it's weight. And it depends of the gravitational field, which in the Earth is 9.98 meters per second, aka second squared. Well, and so here we have a weight going down, right? So we can see that when we have a rod, it's a rod. Let's say it's 10 pounds. 10 pounds. So if we are going to hold it with our finger, exerting a force of, we have two fingers, of 5 pounds on each side. 5 pounds, right? But there is a place such that we can put only one finger and hold it. And so we would be exerting 10 newtons, 10 pounds, which is right about the middle over here. Here on the middle and on the middle axis on both sides. If we make like kind of a cross, okay? Right in this point, there is a center of gravity. And we can put a finger up here and we can hold it with only one finger, and we have an equilibrium. And if I put a something that's holding it here, for example, something that's holding, it would go down this way, but because we have a torque, we have a mass. The mass is equally distributed in every place. So we have a mass going down here, but it's not only that mass. We have this times this distance over here. We have a mass down here, which is force times R. Well, that's torque. You have a torque. And so to counteract that torque, we're going to use a weight, for example. We can put a weight over here. And so this weight times this place over here is the same thing as this, let's say R1, and this is R2, and this is F1, and let's say this is F2. It's the weight, right? F2 G F is equal to MA, but in this case, it's G. So, you want to know F? It's MG. All right. So we have that MG R2 must be equal to F1 R1. All right. So yeah. And we can also see the point. And we can also see, for example, we have a triangle. Let's say an equilateral triangle, right? And we have the bisector. Oh, I have a few three angles over here, triangle. And if we bisect them, aka sect is cut, divide, by two. So if we were to divide all the angles two, we'd find this point over here. And that point is the center of gravity. If I were to put my finger there, I would be able to sustain it. All right. So yeah, another thing that I would like to say is that it's on an equilibrium. So the forces are equal on both sides. And what do I mean by that? Let's say I have not a great drawer, so I'm going to take a picture. Right, so here we see like the a few exercises. So this one, what I would like to show is that we have a weight over here. Let's say that all these weights have the same weight. Okay, so we have a weight over here, down here, W. Right, but now we have this arm length. That's called R. And so what you're actually, the force that you have to exert upward is what that force required. The force required is equal to the weight times R, right? And in all of them, you're going to the force is equal to everybody. The only thing that will change is the radius. So for example, now in this case over here, we have the same weight, for example, but now this is the radius. So it's considerably less. And even less this, because it's holding down, we have only this radius. Okay, and also it's not holding up, it's holding downwards, so it gets easier. You can see that if you hold a bag like with your arm extended to the ground, or you hold a bag over your head, is way more difficult over your head because it's also here it's considerably less because also it's closer to the body and it's lower. But what I wanted to show you is this. This is very important. This is a torque. And the last thing I would like to say, the body diagram of, we have a wall, we have the ground, right? And we have a, forgot the name, a ladder, a ladder, ladder. And so it has a considerable weight, okay, W. And what is holding that letter? We have a friction force, right? So it wants to go this way, all right, because of the weight. But we have a counter force. That's the friction. Also, this wants to go down, all right, because of the force, the weight. So we have a friction also here. And so this force and this counteracts the weight. Okay, so that's why it doesn't fall. So this is very important.